Okay, welcome back to our silicone course, silicone for personal care applications. I'm very glad to spend time with everyone together to discuss chemistries around silicones for personal care applications. So let's start with a review of the course and where we are at this moment. We started with some basics of the silicon chemistries, and we have gone through some very basic understanding of the PMS, fluids, and etc. And from last class, we started a section which I want to focus on understanding of silicone's application in hair care. Particularly last class, we talked about silicone emulsions, and we had some good discussions around silicone emulsions, and we had some good questions around, PMS emulsions versus amino emulsions. At that moment, we actually mentioned amino silicones. In addition, we had some good question out there asking whether the emulsion is necessary, emulsion versus fluid, and we also asked us questions about PDMS versus aminos. With all this, we talked about aminos, and I promised in the class 8 we will have a summary discussion around everything we know about silicones in hair care. Oh, can we really do this? Can we really summarize everything for silicones application in hair care? Probably not. Just like this course, I'm probably not going to be able to summarize everything about amino silicones for personal care. But I will be able to, I think I will be able to summarize something I think important about the aminos, some basics. So this is the goal of this particular class. Okay, let's get started. Okay, so what are the aminosilicones? Aminosilicones are PDMS fluid modified with amines or quaternary groups. What's the outcome of those modifications? First, and the most important thing, probably not. One of the very important thing is it introduced polarity to PDMS. We talk about the PDMS. Why I write it PMDS? It should be PDMS. Sorry, PDMS. Kind of. So we talked some basics about PDMS. What happened about PDMS? We talked about the methyl groups, the free rotation of the methyl groups, dimethyl groups, and as a fact, this free rotation screens the polarity of the SiO silicon oxygen bond. So as a result, PDMS is actually very nonpolar, very low surface energy. As a result, very hydrophobic. However, there was many applications you want to introduce polarity into PDMS. For example, which we're going to talk in the class 9 and 10, we're going to talk about polyether modified PDMS, a huge group of silicones that has a range of the application as wetting groups and also as emulsifiers. But here we're gonna have some flavors of polarity, um, and and actually this is the most important. What most important is you're gonna have charge group. Why? As everyone knows, common primary amine gonna have pKb less than 4 for sure. That means protonated acid is gonna have pKa over 9. That means in the normal pH range of a cosmetic formulation, you will have a protonated group. That means you're gonna have positive charge amine groups. This is going to be more the case if we're talking about secondary and or tertiary amines, which means which are associated with amine that has pKb even smaller and protonated acid going to have even higher pKa. What are the amino groups and what are structures? We're going to talk about some basic chemistries later on about aminosilicone. But before that, I want to show some of the chemical structures of the aminosilicones we're going to talk about. For example, on the right top, we see Amino the most common aminosilicone used in personal care industry. And we're also going to have a talk about the bis amino purple dimethicone as well as bis amino purple dimethicone. Also, the quaternarium group functionality can be introduced to PDMS. I show here in a simple example of silicon quaternarium 22, which has 3 amino groups in this kind of T-shaped silicon chain. Okay, so as I promised in the prior classes, each time when we're talking about the silicones, we're gonna ask questions. Which are the most important things we need to ask? Right questions. As a formulator, we're gonna talk to the suppliers. We're gonna talk to other folks that could educate us. But before we receive all the educations, we need to ask the right questions. What are the questions I think are the most important ones for aminosilicone? I summarize a couple. First, why I should use aminosilicone in the first place. What are common aminosilicones? I talked a little bit, but why are they different? Okay, we're gonna talk about those on a very high level. What are factors affecting an aminosilicone's performance? Okay, this we're gonna go a little bit into the structure function property relationship a little bit. When talking about chemistry, material science chemistry, material science slash chemistry, we're talking about the factors affecting the functions. And then another question everyone would like to ask is every supplier sells aminosilicone. Are those aminosilicones the same? What are the differences? Good question, very good question. You should ask suppliers as well, but I hope to at least initiate some discussion with you. Some aminosilicones are sold in emulsion forms. Some are sold in neat fluid. Any performance difference? When you use, I think to my best knowledge, most of the aminosilicones in the market are supplied as by suppliers as in emulsion form. There must be some reasons behind why they're doing this. But the question for us is why we should use those aminosilicones sold in emulsion forms, or we should actually use in neat fluid. What are the implications to the end use in terms of performance? Would long-term use of aminosilicones in here brings up these two build-up? What are which is very difficult to remove. A very good question, as well. $1,000,000 question for sure. Briefly, I can talk about this. I think this is on the high level related to different type of aminosilicones. Many aminosilicones are going to be very easy to be removed according to studies in the literature. However, some aminosilicones, especially those has very high charge densities, may be very difficult to be removed. Okay, but we can talk a little bit more. So how are we gonna organize this class? This is what I thought. I would rather talking about the end products, and I personally feel the company to talk about, and the company has been doing a very good job of using aminosilicone is actually P&G. Sorry, I'm not working for P&G. But I would like to do some analysis around P&G's aminosilicone use. It will kind of limit the big scope of how aminosilicone is used because P&G probably tends to use aminosilicones for hair repair, which you will see in the coming slides. But I do think it might be some reason behind this usage. So let's begin. Let's begin to understand how aminosilicones used by one of the major end user, brand owner. They're actually using aminosilicone in conditioners and all the different miracle repair stuff. Let's see a video from Pantene.com. Have we seen this video? Oh no. Let's go back. Why?
Pantene's proprietary amino silicone technology really changed the way that we think about conditioners. These are smart silicones which target the areas where they're most needed. This was really high-tech hair care in the making.
Very interesting. I don't know. I feel I learned a couple of things from this very short video. First, this guy was talking about proprietary amino silicone. That means there's some patent protection. I will talk later in this class that most amino silicones has been used is amodimethicone, which has been used for decades and has the history way back to textile industry. It's very hard to still have any patent coverage on imodimethicone. So another thing this guy was talking about is it was talking about this spectrum silicone has been has ability to repair where it needs to repair, has some specificity, kind of targeted delivery, kind of this kind of concept. This will be interesting. I think that has something to do with why people are using aminosilicones actually in the first place. We'll talk later down the road, but let's learn a little bit more about what painting or PNG is doing with aminosilicone. But before that, I would like to share some understanding of the common formulation framework for hair conditioner. As you may know very well, a hair conditioner this is what I'm showing here is a very common framework for making hair conditioner. This is a kind of tested framework. Many reasons because many hair conditioners are using mass market. That means you have to able to get the price down. In the meantime, you get all these benefits. Also, you want to have very stable supply chain. So you have to use very common ingredients if it's possible. So this is what has been one of the most common formulation type after 40, 50 years. So there must be some reason. Let's look together. So in this formulation framework, which is actually used by PNG, which I will talk later, it involves water. Majority is water plus cationic surfactant. What are the cationic surfactant we're talking about? The BTAC, which has C22 long active chain with quaternarian hair groups and chloral counter, and BTMS, very similar to BTAC, but has a slightly different counter ions of methyl sulfonate as a counter ion. And they're also septamer, which is a secondary amine, also involve very long active chain. Probably septamer has even longer use history in hair conditioner than BTAC, or definitely much longer than BDMS. And with this level, what usually happens is they also involve what they call a co-emulsifier, because once they have a cationic group on this surfactant chain, as long active chains, it becomes a cationic surfactant. And another very important, actually the majority component here is a hard alcohol. Those are cetyl alcohol, stearyl alcohol, or the mixture of the both. Carbon 16 or carbon 18. And what people do is they heat those waxy materials or solid materials up to 85 or even higher degree, and then they apply homogenization of very high shear to make a jaw network. What is the jaw network? The jaw network form here is kind of like a laminar structure of a cell membrane. You have those active chain, very long, hydrophobic, tend to packing with each other, maybe short distance crystallization formed, which they also call the liquid crystal structure. But they form a lamellar kind of three-dimensional structure by arranging those cationic long chain surfactant as well as those long chain alcohol. Once this John network formed with this continuing cooling and this liquid crystal structure formed throughout the cooling stage, you get a viscosity increase. A John network is formed. So the next step, which most of the this type of conditioner makers are doing, is start to add additional conditioning agent for whatever the conditioning benefit they want. For example, amodimethicone and amino silicone we're going to talk about later, or silicone gum, or any polyquatanium salts, etc. Those are regarding as a special magic ingredient for all the claims. Although we have to remember those cationic surfactant and hard alcohols are also very good conditioning agents. They actually do their job in addition to whatever these magic ingredients you have. So I want to highlight, the conditioning agent is not just this, but also the cationic surfactant like BTMS or BTAC. So what's happening? I mean, sometimes those magic conditioning ingredients are added in emulsion form, which I talked a little bit last class about emulsion silicones, silicone emulsion form, silicone emulsions. Other cases they're added as neat fluid. There's some difference, but in my opinion, in the end, those conditioning agents is kind of suspended in this John network, form quasi-stable kind of suspension of those conditioner ingredient. They're not necessarily, even if they are added in emulsion form, the emulsion might not exist once you get everything there. Again, in this step, no hot shearing is needed. Okay, and then the temperature can be further cooled down to the extent, for example, below 50 degrees C. At this stage, you are going to be able to add perfume, chelators, preservatives, or any other claim ingredients you wish to add, amino acid, or whatever things. Okay, so this is a common formulation framework, which P&G has been practicing for a very long time, for many reasons. Okay, let's see how this put together with amino silicone. I'll give you an example. I'm giving here an example of hair masks. You may know very well about hair masks. It's a little bit different from hair conditioner. It's kind of a more repair type of hair formulation. It's kind of intense repair. You use hair mask after you doing shampoo. You got very wet hair, but you apply hair masks and leave for actually longer time what you typically do for hair conditioning, which is normally take only 1 or 2 minutes. For using hair mask, you are gonna do for example, 10 minutes when you basically step out of shower, playing hair masks, hope all the good stuff aren't gonna be on your hair and get all your hair repaired. And then you start to rinse. It's gonna be good for professional salon. All right, okay, let's see what the Pantene has been using and what type of formulation has been evolved. I'm showing over the past 20 years the evolution of the formulation ingredients within Pantene hair masks. And picking four here, different years of they're on the market. Okay, so first I'm highlight the ingredients you recognize very well. Zero alcohol, cetyl alcohol. They might add it, as a mixture, as raw material cetyl alcohol. Maybe they're gonna have a little bit more cetyl alcohol added, a little bit more cetyl alcohol added. I'm not sure, but it doesn't matter. Everyone use it. And then the next thing they're adding is the cationic surfactant, long chain, septamer, BTAC, BTMS, BTAC, C22 for BTAC. Okay, so this is the ingredients that forms John network. Okay, let's look at amino silicones. Where are they? So I'm highlighting those magic silicones where they are in the ingredient list. 20 years ago, what Pantene was using is a mixture of a D5 and dimethicone. Likely, it's a gum blend, kind of very high viscosity dimethicone, kind of diluted with D5 for easy processing. And for the one in 2006, they started using amodimethycone instead of dimethicone. I mean, still, as of today, many companies are still using either dimethiconol, or imodimethycone. We talked a little bit in the past, and I'm probably going to talk more in the next class when I'm going to do a here kind of summary for all the silicones usage. Okay, about 10 years ago, there was a big shift in terms of how, what type of silicones P&G going to use for their flagship Pantene conditioners or Pantene conditioner type of products. Bis-amino purple dimethicone. And then very recently, talking about 3 or 4 years ago, they started using something different. Silicone quatinium 26, for example, or silicone quatinium 25. Very interesting. We have a lot of questions to ask. This evolution must mean something. It must have found something that kind of for their understanding that they do this technology evolution. There must be some innovation going on there. Okay, let's look at more. One product I think is really interesting, really caught my eyes in the past couple of years, is Pantene Probably 3-minute Miracle Deep Conditioner, kind of magic repair. I would assume there may be some setback in the past 6 months for this type of repair, quick repair type of stuff because of all this COVID virus situation. But I think in the long term it's still gonna be take off again for this miracle repair conditioners. Let's see some commercials from Pantene. Maybe it can tell us something.
Color, color, color. Without the frizz. Really? I'm stronger now with Pantene 3-Minute Miracle Conditioner with Provitamin. Pantene 3-Minute Miracle. Use after every shampoo.
Okay. I think I at least learned a couple of things talking about coloring. Very kind of a common way to cause hair damage. Talking about frizz, which something typically associated with damaged hair. And then it's talking about this 3-minute miracle kind of conditioner. There has been quite a lot of buzz around this type of miracle deep conditioner. Let's together look at the ingredient list. First thing formulator is going to do, right? Okay. There are quite some kind of small separation of different products, kind of fine differentiation for this whole 3-minute miracle conditioner series. I just picked 4 here. Common ones for frizzy hairs, for damaged hairs. I think the repair and protect probably the most common, most high sale one among 3-minute miracles. There are also ones for increased volume for very fine Caucasian hair maybe, and also common issue is the dry hair, perception of not very moisturized hair. And if we look at the ingredient, we will find they're virtually the same. This is what if I want to tell something, this is what I'm trying to tell you. You have stearoyl alcohol, cetyl alcohol. You have long chain cationic surfactant, and then they have this magic bis-amino purple dimethicone we saw in last slides. So there must be some reason. There must be some reason. We must learn something for aminosilicones. If we want to understand aminosilicones, I would start here. If you want to formulate aminosilicone, I would start here. I would do more digging into bis-amino purple dimethicone. I would look at all the different products from P&G. I would look at all the literature in the public domain. I look at the patent literature, try to understand what's going on with the bisamino propyldiamethicone. Okay, let's just try to see more. Um, I'm not working for P&G again, but we know Pantene Pro V Daily Conditioner is a very high sale conditioner, probably the top one. I think this is what they're trying to say here.
What you're about to see is not a trick, just pure science. Meet the static generator. It can show hair damage. The more hair standing up, the more damaged it is. The less hair standing up, the less damaged it is. And why is this side not standing up? Because of the world's #1 conditioner brand, Pantene. We used it to nourish only this side of her hair. Its smart Pro V formula helps find and repair damaged spots other conditioners cannot, making hair stronger, shinier, inside out. No camera tricks, no special effects. Just pure science. See the difference the world's #1 conditioner brand can make. Pantene Daily Intensive Conditioner.
Okay, great. I always enjoy watching commercials from those big cosmetic companies. Those are fun, and also they have to be very careful. They avoid all the lawsuits from bounty lawyers or FTC about false claims. So they have been very careful. If they claim something, it must be lots of study behind it for claim substantiation. But what I learned here, I want to summarize. First, they claim Pantene Daily Moisture Pro V Daily Conditioner is the #1 brand. It must be true, and we must. In that case, if it's true, it should be. We must study it. Why? From the formulation standpoint. Okay, this is the first. The second, they were talking about, they're able to repair the spots has been damaged. Kind of aligned with what this first video the guys talking about. Very targeted repair. And also they have shown some very fancy kind of hair freezer by the static generator. I'm actually for that part I'm not 100% agree. Damage versus healthy hair would have a difference. I think there was many other things about this freeze up by the electricity, and even you probably have both very healthy hair. You apply one thing versus the other, you might have a difference. Even your hair is the same. Kind of I mean, there was lots of things. I mean, basically, I was trying to see there was lots of things behind all the hair stand up. But let's somehow have fun together looking at the daily conditioner and the ingredient list, which is my #1 job every day. Okay, Pantene Prairie Daily Conditioner is a little bit complicated, more complicated than most other things from Pantene because they got near 20 different fine differentiated conditioner under this daily conditioner series line, and they try to cover all different claims. They're not actually selling in Walmart. The Pantene will only sell Head and Shoulder in Walmart, a little bit lower level brand. But for daily conditioner, probably daily conditioner, in the place you can find this range of the differentiations. I list a couple here. I think I list 16 here. For example, I think the repair and protect probably is a very high sale fine differentiation for damage or overwork here. This is what the Pantene Pro-V is about, the whole repair concept. They have the curve definition, anti-breakage. If you got more hair breaks, or all different things, or you have automate 10, which is you can do one thing for everything. But if you look at ingredient list, you see the same patterns. I'll hide a little bit, but this is very similar hair conditioner chassis plus amino silicones, and this particular amino silicones at this stage of the evolution about 10 years ago is this amino propyldiamethicone. The next slide is the same thing, showing a little bit different, little bit more different differentiations from this whole collection. I see shine is really about shine enhancement. Is all different things. They might find some performance difference by fine-tune alcohol selections and particular cationic surfactants, and they might use slightly different bis-aminopropyldimethyl, for example, for repair. They might use a little bit more, and they might sell the price a little bit higher. And then for more this kind of virgin or non damaged hair, they might use a little bit less, and they might actually sell for a little bit lower price. Okay, the next slide, and you might kind of pay attention to this as well. Pantene Pro Expert Conditioner Series, launched about 2006. Quite a buzz here, kind of slowed down recently, and they kind of focus mostly for age defy in the past a year or two. They got quite success, I think, just for this fine differentiation among the Expert series. Very distinct packaging, the black packaging with the golden kind of painting, and of course sell for much higher price as well than the daily moisture. I think for per milligram probably sells 3 times more. But if we look at closely in terms of what the ingredient is we see very similar things of the hard alcohol. We're gonna see this long chain cationic surfactant, and then we're gonna pay attention to this a little bit different things here. Silicone cutanium 26. We're gonna know a little bit more about silicone cutanium 6 in coming slide. But it seems to evolved, as I showed in the early slide of hair masks, from different silicone, and then they come to the silicone 20, cutanium 26, and selling for a little bit higher price. Really pay attention is the age-defying theory, and it seems to really gain traction for the younger hair. Their commercials I'm going to show in the coming slide. Very interesting. Okay, this is silicone. Cutanium 26. Again, the same formulation architecture apply to all different cleansing hair types. Let's see this.
For your demanding hair comes an answer. The Pantene Expert Collection. For hair that acts up to 10 years younger, try Age Defy. To thicken hair as if you've added up to 6,500 more strands, get advanced thickening treatment. To repair 2 years of damage in 2 minutes, it's advanced keratin repair, approved by even the most demanding hair. Age Defy, thickening, and advanced keratin. The Pantene Expert Collection. Demanding hair demands an expert.
Kind of a couple of things. 10 years younger appearance, repaired 2 years damage in 2 minutes with keratin repair, stuff like that. I think particularly for keratin repair, this 2 minutes repair. If you look at ingredient, I believe they use both amino silicone as well as particular silicone emulsions that talk in the prior class. I think that's probably likely from the Dow HMW 2220. This one, very extremely high molecular weight, which I talked in the prior class. So very interesting. Very interesting. I believe this one is sell, especially this keratin repair, 2 minutes repair, they sell at very high price, and they also sell for 1 minute repair at a 25 milliliter package, and really premium price. But if you look at the ingredient list, you will recognize the exact same architecture, exact the same. I think the silicone cutanium 26. I bet the difference is the silicone cutanium 26 use level. The different ones from 3 Minutes Miracle, from the Golden the Expert series, maybe around 3% if I take a guess to all this, age defined 2 minutes to 5 or even higher than 5% use level. Again, if you want to achieve 2 minutes repair, come on, it's not amino acid claimed by Pantene Pro-V for the long-term repair. It's gonna be some aminosilicone for immediate repair. You cannot repair in 2 minutes. Buy some magic hair actives for your hair grow differently. Your hair not gonna grow much in 2 minutes. It's gonna be some chemicals, that some polymers that gonna have some instant benefit. And then if I by now I try to convince you aminosilicone is something that is very effective in hair repair. Of course, if we want to understand, and the question we're going to ask is, mm, what are the factors, what Pantene has learned, what P&G has learned, what type of structure factors are important, etc. We're going to look at their patterns because when they write a pattern, when they try to cover something, they want to cover something they studied hard, what they learned from the hard studies. They want to very specify those physical chemistry elements and then try to cover those physical chemistry elements, and those elements are really important, definitely, because they spend a lot of efforts for those understandings, and we want to learn from their patterns. If we look at this aminopropyl patterns, I think there's a huge pattern family here. But we look at some, the pattern has been focused uh, on the aminosilicones that has very low charge density and terminal function. You must tell us something. Seriously, low charge density. Why? What is low charge density mean? And of course, bis-aminopropyl we talk about is terminal functionalized. This is bis-aminopropyl dimethicone. If you look at plutonium 26 or 25, we study spend time to look at all these patterns issued in different countries. Of course, they have different strengths in terms of coverage, but they all focus on block copolymers with plutonium segment or plutonium linkage and a very long silicone segment. Kind of define the polymerization degree of silicones. Interesting, right? Those definitely something we're gonna pay attention. Okay, so I think by now we have a very good, interesting introduction about aminosilicones. We will gonna talk in the next class all the different applications of aminosilicone. And also silicone in general for hair. They're not limited on hair repair, on this younger, healthy hair outcome. But this is the focus of this particular class. I choose to focus on this aspect because I personally believe this is what important for aminosilicone. Let's review some basic chemistry after all those learnings. Common aminosilicone for hair conditioning, we talked about those structures. It kind of turned out the most common one is amino. Must be a reason, but we look at the structure. This amino side, this building segment, this whole molecule is actually prior to be used in hair care. It's kind of in the laser kind of treatment in the fabric softeners, etc. Have secondary amine, primary amine. They typically they actually are going to have two charge here. Once in the natural pH. And also this is this segment is commonly used as a segment for a coating coupling agent. This particular silane. This aminopropyl silicone I talked about is terminal modified. If we change this amodimethicone structure to a simple one, we actually got a little bit more complicated inky name, aminopropyl dimethicone. Imodimethicone probably got the inky name earlier. They are lucky. Okay. Beyond that, they are selling a little bit fancier aminosilicones. Show here, they could be alkyl modified. Common ones are N-chain long chain and capped long chains, long echo chain. Okay, we're gonna talk about active modified silicone as I promised in class 11. Liquid becomes extremely long active silicone. Long echo chain could change the silicone from kind of fluid, no matter how high the viscosity is, to a solid. The forms waxy structures for many structuring, for example, lipstick structuring agent, etc. Silicone form more waxy coating than amino silicone gonna do, like typical silicone would do. As a result, it's kind of typically understand the sensory could be further enhanced in terms of distinct coating sensory. Again, I'm talking about my personal opinion. I personally is not a big fan of active modified immunomedical, for example. I just feel there are quite some long active chain small molecules in a typical hair conditioner formulation. Those PDMS, Cetoacol, those type of stuff, we formulate well if we find a way to deposit well. You're gonna have very similar sensory. Kind of not what silicone is really expected. But again, other silicone formulators would have much better luck than I would do, and they really like it. They make really good formulation out of some Dalconing or momentive active modified aminoacetone. Fair game. Another modification is polyester modification in addition to the aminos. The understanding is, I can talk a little bit more here, is with LQ functionalization, this potential assist is gonna be able to assist deposition. I talked a little bit in the past classes for non-functionalized PDMS. Um, they kind of tend to coat or deposit on non-treated hair. They kind of more have more preference to do that than damaged hair, because non-coated hair, non-damaged hair got lower surface energy, the keratin structure is more intact, etc. While the damaged hairs area becomes more hydrophilic and potentially negatively charged. Uh, as a result, this hydrophilic side in the water kind of less likely to be coated by silicones if you do all this surface energy, surface tension calculation, try to see the free energy difference when you study all the the new surface area generated and the old surface area disappeared because of the coating. You kind of find that for damaged part, for hydrophilic part, you might want some polarity in the silicone structure to help or to assist the deposition. Even for all those things, the silicone gonna have a lower surface tension in the first place. So the understanding of what people are talking about is polyester modification help or assist deposition to some extent. But in my personal opinion, when you had high amount of polyester modification, as some suppliers doing, to the extent you make the polyester even soluble in polyester modified, I mean immunamazole even become water soluble or soluble in polar solvent like glycerin, you kind of lose what you want for the silicone. You got too much non-silicone component. Again, personal preference. Not a big fan of very hydrophilic ones. Uh, but with some modifications, I understand they could help the water retention a little bit on the damage side, potentially anti-static, etc. I list some common uh, polyester modifications here. The first one, you could be kind of amino silicone copolymerized of polyester modified silicone segment. as I show here, or you could form a block copolymer structure, kind of structure, for example, momentive, like to do. The red here, for this particular one, the red here, a polyether segment, and the link between the blue one is a silicon segment, and the link here could be positive charge. For the chemistry use, I might be able to talk a little bit about the political chemistry here. As you know, there are many silicon coordinates in our Inky dictionary. Coordinating 1, 2, 3, 4. Silicon coordinating 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I showed you silicon 26. Silicon 26. What are those silicon coordinates? They are positive charge coordinate group. This series, many of them, or even majority of them, are prepared by reacting epoxy modified silicone, as I show here, with a tertiary amine. This epoxy modification, this type of silicone is very common in the coating industry, or in this one is a coupling agent. This siling of this could, treatment on the surface could result a surface being very reactive with epoxy group. So this is kind of very common things in silicone suppliers as a building block. This epoxy could react with either primary for sure, secondary amine, but when react with tertiary amine, it forms a permanent charge quaternary group. I mean, of course, if you react with the secondary amine, you're going to have a tertiary amine group functionalized. Majority of those silicon quaternium series are made by this particular reaction. And if you spend some time with the Inky dictionary, you're going to learn more about it. There's some other silicones being sold by suppliers. I think they become more interesting with additional chemistry. Some of them, recent ones being promoted by some of our suppliers, a lightly cross-linked one. They introduce slight cross-linking to typically linear amino-modified silicones. Many hopes beyond that. For example, film forming, long-lasting on the hair. Once it deposited on here, the molecule becomes much longer. They form kind of two-dimensional structures. I provide you 2 examples here. You can look at the chemistry. For this one from Dow, I think the chemistry is the one I just talked about. Epoxy react with diamine. The diamine going to be a cross-linker to cross-link the epoxy silicones, and the reaction part going to form tertiary or quaternium groups and become positive charge. They're kind of able to control the cross-linking density. And this one from Walker is basically amodimesicone structures, and once it do the reaction, I bet they put some T group silicone building block with 3 function groups, so they able to kind of making a kind of T structure out of it, slightly cross-linking by the T structure. Again, we have to be a little bit careful to think about their claimed benefit. Many reasons they do this type of all different fancy chemistry. Sometimes they just want to make patents for patent reasons, or they want to avoid other people's patent to design a little bit new chemistry, or sometimes they really do something benefit. But again, for fancy chemistry, they might associate with a little bit higher cost. But as always, we can spend time to understand those. Okay, let's see. Amodimesicone. We're gonna go back to amodimesicone. So many amodimesicones being sold by many different suppliers across the globe. Everyone sells amodimesicone. What is the difference? As a formulator, you have to think about it. We talked about something in the past slides, so may already help. But amodimesicone are supplied by suppliers either in emulsion form or as neat fluid. The suppliers want most of the imodimers, actually, to my best knowledge, are supplied by in emulsion form. The anywhere from 30 to 60% silicone content in emulsion form. The emulsified could be cationic or cationic plus non-ionic or just pure non-ionic emulsifiers. There are even cases in anionic emulsified immunomedicine. Not many sold in neat fluid. Why? Um, this is what I think. Amodimesicone has amino groups. In neat fluid, it's kind of many stability issues. First, once it gets oxidized, it turns yellow, as we know for most of primary amine. Or even secondary amine tend to be oxidized and they tend to form yellowing compound. If you supply emulsion, you will not notice it because the whole light scattering is gonna kick all this light absorption effect out of the spectrum. Uh, and and also, if it's a neat amino-dimesicone fluid, there's another issue of gradually increase the viscosity. It could be very easily increased out of spec in a couple months, depending on your storage uh, condition. For imodimesicone, you got amino groups. When it absorb moisture and the carbon dioxide, it tend to be protonated. Once it got protonated, this cationic group becomes very incompatible with the rest of the amino group. The silicon group. They tend to form non-covalent association along the polymer chain, and restrict the mobility of a polymer chain, resulting in increasing viscosity, phenomena called structuring by many silicone suppliers. But once you put into emulsion, those issues no longer exist. As long as you get enough surfactant, you're gonna have very stable raw materials over 1 year's shelf life easily. Okay, we talked about this. Again, another reason amodimesicone tend to be supplied in emulsion form is it's going to be cheaper to prepare in emulsion form. Imodimesicone emulsion can be prepared by mechanic emulsification. We talked in the past. That means you form imodimesicone fluid first, and then you add water emulsifier, and you try to emulsify it to form an emulsion. Or you try to emulsify all these individual monomers that used for emulsification that form the polymers. You emulsify first, and within the emulsion, you polymerize. The emulsion polymerization and result amodimesicone emulsion going to be a cheaper way for suppliers to produce. You're going to have an easy way to form emulsion. They tend to, hide a lot of small issues about the silicones and the structure of the molecule, blah blah blah. What's the downside of emulsion, raw material supply emulsion form? One downside is D4, D5, D6 content. The typical way of preparing it, they start with cyclics and they do the ring opening polymerization of the cyclics together with the amodimesicone kind of a structure, kind of element, and then they do with end block things. This one has only one cyanide groups, and the other end is there's no functionalization, so this is going to be a cap end cap the whole chain. But this is going to have the reactivity on both sides. For these reactions, you're going to have residual cyclics, and for this D4, D5, it would be a little bit easier to be removed when you're doing the neat thing. But once you're using emulsion, you got all the water. You do typical way to remove it is a vacuum at high temperature. It's going to be hard with water. So an issue here would be D45 content for the emulsion polymerization without amino emulsion. In my opinion, personal opinion, a little bit more expensive for the amino emulsion from the mechanical emulsification, but potentially going to result something with lower D45B6. An attribute becomes more and more important for our formulators. So those are the things you have to be very careful when you select an imodamescin from a particular supplier. Another thing is I didn't mention clearly. When you're doing the polymerization, you have to understand the degree of the polymerization. One thing to understand for this particular one is understand the cyanol content, ACIOH content. Even you have N cap agent here, you might not doing a good job here for particular batch. And if you have extra cyanol groups, you may kind of have some residual activities. So you might have some inconsistency from batch to batch in terms of performance on here. So those are the things we have to pay attention when we select amino from any supply. All right, let's move on to the next stage. We have, for everything we understand to this moment, I think we have a good learning. You probably know the factors important to here conditioning functions. Most important is the here repair functions from the silicone. I took a picture from Walker.com. This is from Walker's. Is about Walker's opinions of how silicone ended on a hair fiber. They try to show the blue point here is a positive charged amino group. They're able to anchor the wear on hair surface through charge interactions. And then they leave all the silicone chains uh, mobile there. Kind of half true image here. I'm not sure I'm 100% agree with what's drawing here. But one thing here is it seems everyone aligned that charge density is important because it kind of affects the degree of freedom of a polymer chain, of a silicon chain on here surface. The more charge density, the more amino anchoring on silicon group. The silicon polymers, and that means you have less silicon chain, less mobile silicon chain. You kind of lose everything you want. You can kind of less of the silicon you want. So charge is kind of understand charge and density helps immobilization on the hair, potentially susceptibility, deposition, etc. But your chain mobility on the hair lose, the freedom, chain freedom, degree of freedom lose. Of course, charge density and the silicon chain length between the amino groups kind of correlated. The higher charge density, that means lower chain length between amino groups. And overall, there was a molecular weight effect. As we talked in the past, molecular weight play a big role for PDMS and its susceptibility on any surface. All right, so this and what else? This is just a little bit more illustrations from Momentive about low charge density versus high charge density, and it shows a very similar kind of concept. Lower charge density kind of correlate a high degree of freedom for silicon on hair surface. High charge density kind of correlate to lower degree of freedom for silicon on hair surface, and for this all this silicone sensories and lubrications and all different things associated with silicone, you might want a high degree of freedom for silicone on hair surface, and that means you might want a lower charge density. And that may explain why PNG patterned the way it patterned. So there are other things. There are other things we learn from, for example, from Pentine's pattern, PNG patterns. They're talking about where the aminos is located. It might be some reason because for the pattern reason, for just for novelty reasons. But we have to learn a little bit more because these are different aminosilicon with different special arrangement of amino groups. For example, imodimethicone. The structure is here. There are different ways, actually, there are different ways to synthesize. You can have a random distribution of the amino groups along the chain, or you can have more kind of control groups. That can be resolved by not using the D4, D5 cyclates as the starting materials monomer, or but use like more longer chain silicone bifunctional two-cyano ended oligomers to have a little bit better spectral control. I'm not fully convinced there much performance difference here, but some suppliers are claiming benefits out of it. Terminal aminos versus, we talked about terminal aminos, bis-amino propyldimethyl. This is kind of kind of interesting. Terminal aminos, if you have a longer silicon chain, it will be associated. It is going to be associated with lower charge density. We talk about and talk about this importance. And also, if you only have two anchor groups, one of it might not function well. You kind of associate with high mobility, high freedom of the silicone on hair surface. And in my personal imagination, it might even have some mobilities with terminal functionalized. It might kind of be able to accumulate more on the damage side. Another thing about the silicon cutanium 26 is ABN type of block-copolymer means. I show a structure here. I show this here from Momentive, the kind of silicon chains, very short linkage between blocks, and each linkage come with positive charge. This is something that's been sold by suppliers, especially Momentive. How to say? I think it kind of novel from a structure standpoint. Suppliers want to sell novel things. Structure standpoint, they want to sell something with patent protection and higher margin. Understandable. But we have to be a little bit skeptical here about the structures. But again, it appears to be something interesting. At least PNG is interested and use it. All right. And that will be what's next on. All right, we'll do a class summary. We have already 1 hour here. Thank you for being staying with me for the past hour. What have been talked? We talked about amino silicone. We didn't go through every different usage of amino silicones for hair care and potentially for other applications beyond hair. But we focused on the hair conditioning part of the aminosilicone. We started with some basic knowledge about aminosilicones. They have nitrogen item, potentially positive charge modification on silicones. And then we have a flavor how used successfully by P&G in a variety of products. And this is associated with my understanding of what aminosilicone is most efficient in formulation is doing the repair, damage repair, this last minute damage repair after you have screwed up your hair. All right, and then I talk about some basic chemistry of the aminosilicone, just kind of lay out the different aminosilicone you would expect from suppliers, so you kind of have a little bit you're gonna be a little bit prepared when you talk to suppliers. You kind of know they're not selling you something magically new. And then talk about factors that are important to the performance. Again, for this class I only focus on the repair. That means get back to this lubrication of the sensory of the hair. In that case, charge density kind of important. Kind of relate back to PNG's patterns and PNG's use of the bis-amino purple dimethyl, which is a terminal functionalized with extra very long polymer chain. You can read the pattern. It claims something like 1600 repeating units or something, or even higher than that. Quite a long chain. And then we kind of we can also talk about also other possibilities. This is this class. The next class we're gonna talk about a summary of how silicone is used in the hair care. Uh, Silicone used in the hair care. I mean, of course, in shampoo they want a very good vacuuming. Beyond that, has a lot to do with the hair repair, stuff, silicone related. We're gonna talk a little bit about what the healthy hair would be, what does the elements associated with outlook of healthy hair, what is the hair damage, what's the cause of hair damage, etc. Because a lot of things about silicone is a repair. And then there's some other elements about silicone's application in here. For example, the color retention, fast dry, etc. We asked some questions in that class. I don't think I have all the answers, but at least we can lay out all the claims silicone supplies has made and being adapted by some of our brand owner friends. And then we can see whether there could be explanation of all the benefits. It's kind of expanding. All right. Hope you enjoy for this class. Let's go and get back together for the next class. Thank you.